All right, so for the last couple sections, we're going to dip our toes into a little bit of Calculus 2. For 7.1, we're going to do what's called integration by parts. And first of all, how do you know when to use integration by parts? And usually it's going to be because you think you can use U substitution, but you've got too much in the variable department, okay? So it's always set up with a multiplication / division problem, okay? So it's not going to be term by term, anything like that. But what we're looking for, so let me just give you an example. If I have something like x, and then x squared plus 1 to the 7th dx, okay? So here's what I've got. If my u is x squared plus 1, then my du is 2x dx. I got the dx, I got the x. I just need the 2, correct? So I would go whipping along and I would go down that pathway. But what happens when I do something like this to the 7th dx? So notice that everything was the same, but now I've got an additional x being multiplied on the outside. So I have u equals my x squared plus 1. My du equals 2x dx, and all of a sudden I'm horrified because I have an additional x here. And that additional x is causing issues. You cannot just divide it away. You can't just say, oh, well, I'm just going to divide by x on this side and kill it. No, you're not allowed to do that. So what we're going to do is called integration by parts. Okay, so it's what you head towards when U substitution doesn't work. Okay, so what we're going to do is we're going to identify u's and v's, du's and dv's, and then apply this formula. So I've got uv minus the integral of v du. uv minus the integral of v du. And this needs to be at the top of your page for every problem that you do. Okay? Because this is going to be the pattern that you follow. So let's walk through this and we'll see what's going to go on. So hang on, I can't see. All right, so for our first one, we have the integral of x e to the 6x dx. Okay, so let's just for kicks try U substitution. So as soon as I see an e to the, I know that my u, holy cow, I'm so sorry I yawned. I know that my u should be a 6x. Okay, so my u should be the exponent. Well, then what's your du? Your du is a 6 dx, which means I have an extra x floating around that's really causing issues. I'm really quite disgusted with life right now. So what I'm going to do is let my dog outside. Hang on, I'll be right back. All right, so, sorry. My stupid little dog had to go outside. Anyway, not that you know that because all I did was pause. When I set this up, this x is causing me all kinds of problems. So here's what you're going to do. From this setup, you're going to identify a u and a dv. Okay? What's going to happen is you're going to differentiate the u and you're going to integrate the dv. Okay, so this side needs to be differentiable. You always want your dv to be the more difficult looking of your options. Okay, the other way of looking at it is when you differentiate u, you want it to eventually go away. Okay, so on this first one, my options are x and e to the 6x. Okay, whoever is your dv will get your dx. So I've got two options. One of them needs to be u. One of them needs to be dv. So the easier looking one is going to be your u. So that's going to be x. So what does that leave me with? That leaves me with an e to the 6x dx. So that is going to be my dv. So I have e to the 6x dx. What I do from here is I take derivatives on the left and I integrate on the right. So the integral of 1 dv is v, and the integral of e to the 6x means I need a 6, so I balance with a 1/6 e to the 6x. Okay, so what did I do? I differentiated, so the derivative of x is 1 dx. On this side, I integrated, so the integral of 1 dv is v, and the integral of e to the 6x, I needed a 6, so I had to balance with a 1/6. And then I had a 1/6 e to the u du, not these u's, but those u's, and that gave you a 1/6 e to the 6x. Now you employ this. So I'm going to go up and I'm going to say uv. So u times v is going to be 1/6 x e to the 6x minus the integral of v du. So minus the integral of v, which is 1/6 e to the 6x. So I'm always going to put that constant out front. So 1/6 e to the 6x dx. Okay? And now, if you'll notice, the integration part is very easily done. This part's already done. All we have to do is integrate this. Okay, so I need a 6. So I'm going to balance with a 1/6, which means I need another 1/6. That one doesn't count. So 1/6 times 1/6 is 1/36. Okay, so I now have an answer of 1/6 x e to the 6x minus 1/36 e to the 6x plus c. Okay, and now what's going to happen? If you check by differentiation, you're going to have to use product rule here. You're going to have to not use product rule here, but you will end up getting this back. So you're kind of sort of undoing the product rule is what you need to think of it as. So let's try it again. Let's go a little bit slower. Hang on, I got 20 million papers. All right, so we have, good heavens. All right, so many papers. All right, so let's try another one. So remember, you're looking for a u and you're looking for a dv. So what I have on this one is the integral of 1/6 x e to the x over 12, which I'm going to write as 1/12 x dx, and that's just going to make my life a little bit easier. Okay, so let's try this again. If I use u substitution, just plain old u substitution, my u would be 1/12 x and my du would be 1/12. So this x is causing issues. So now you should immediately start drifting towards integration by parts. Okay, so I'm going to pull my 1/6 out front just so he's out of the way. Just remember, he belongs to everything you do. Okay, so don't forget about him. And now I have an x e to the 1/12 x dx. So what I need from here, I need a u, I need a dv, and then I'll differentiate and I'll integrate. Okay, so here's how, because I'm a visual person. Okay, I'm going to find out this one and I'm going to find out this one. Okay, those are the two that I need to find from here. From there, it's going to be these two multiplied minus the integral of these two multiplied. Okay, so which one looks easier? The x or the e to the 1/12 dx? Okay, so I bet x looks easier. So if I throw an x here, so that's this one, what's the derivative of x? It is 1 dx. So what's the other part? E to the 1/12 x. So I have e to the 1/12 x dx. So I differentiate on this side. On this side, I'm going to integrate. Okay, so the integral of 1 dv is v. The integral of e to the 1/12 x means I need a 1/12. So balance with a 12. Okay, balance with a 12. So the integral of this part becomes 12 e to the 1/12 x. Don't put dx. Okay, and now I'm ready to go. So uv is going to be 12x e to the 1/12 x minus the integral of this way. So I'm going to pull that 12 out front, okay, times the integral of e to the 1/12 x dx. Okay, so 12 e to the 1/12 x dx. So now, can I integrate this? Well, I need a 1/12 again. So there's my 1/12, multiply by 12 again. Okay, so what do I have at this point? I end up with, I'm just going to recopy this one. So 12x e to the 1/12 x minus 144 e to the 1/12 x plus c. Okay? So let's see how we're doing. All right, I'm going to pause for a second. All right, so why did we get this entire problem wrong? You're thinking, I don't know. Because what did I tell you not to forget? I knew my numbers were too big. Don't forget your 1/6. Your 1/6 belongs to everything you do. So it's 1/6 of this entire mess. Remember, c is just a constant, and we can adjust him, so you can do a 1/6 c, but then it's still just c. Okay? So 1/6 of 12 means I have a 2x e to the 1/12 x minus 1/6 of 144 would be, I don't even know what that is, and I should know what that is. Divided by 6 is 24. So 24 e to the 1/12 x plus c. c is just a constant. Okay, so I didn't have to distribute the 1/6 there because 1/6 of a constant is a constant. Okay, so now we've got our answer. All right, don't forget about that stupid 1/6. All right, so let's look at another one. Actually, that's a good place to stop. And then we will pick up on the second video.